Next up, we're going to talk about evaporites. And we've already talked about evaporites in this class, so we're going to move through these pretty quickly. But just as a refresher, as seawater evaporates, we know that seawater is salty because of all of those dissolved ions, those weathering products that were brought down from the source, eventually ended up in the ocean, right? The chlorine, the sodium, the potassium, all these ions floating around. As the water evaporates or as those ions become supersaturated, they will precipitate out as a solid. We know that calcite deposits first when about 50% of the seawater has been removed. And then we get gypsum, then halite, then potassium salt. Now, evaporite beds are often deformed by flow. So evaporites tend to have low velocity. For example, halite salt has extremely low density and it recrystallizes easy. So it's able to flow very slowly, but it can flow. And halite in a sequence of rocks will often be buried beneath denser rocks above it. So all of this pressure pushing down on that halite, which can flow, is going to cause the halite to be squished upwards, right? And this is going to create a salt dome, or what we call a diapir. Basically, these blobs of salt that get squished upwards because of the low density of the salt. And like we talked about before, this is what can create oil traps beneath those salt domes.